everyone. In this video we are going to learn about a problem in RC circuit. Okay, the problem is in the RC circuit shown below, a charge of 100 microcoulomb is stored in a capacitor before closing the switch. So they have given like a capacitor is already being charged with 100 microcoulomb and it is before switching. Okay, and at t equal to 0 the switch is closed to discharge the charge through 10 kilo ohm resistance. Okay, so we need to determine what is Vc of t. So this is a circuit given and we have a capacitor of 25 microfarad and we can see like the charge stored in the capacitor is given as Q naught, okay, because it is a charge. So it is 100 microcoulomb. So first we must know what is the condition before switching. So the solution goes like this, that is initial condition t equal to 0 minus what is the charge? Q naught of 0 minus is equal to 100 microcoulomb. So this is what is before switching. So we need to calculate what is the charge which is stored in the capacitor before switching. So we need to measure the voltage across the capacitor. So it is taken as V of 0 minus. So we already know a formula Q equal to CV. So Q naught of 0 minus is equal to CV of 0 minus. From this we are getting V of 0 minus is equal to Q naught of 0 minus divided by C. So substitute the values which is given in the question, that is 100 microcoulomb divided by 25 microfarad. So you get a voltage of 4 volt before switch. Now we have to see after switching, that is switch is closed at t equal to 0. So now the circuit is closed loop. Now we can see that the current is flowing in the circuit, that we take as I of t. Now we are going to calculate what is the voltage across the capacitor after switching and what is the voltage being used by the resistor. So for this circuit we need to apply KVL. So KVL, if we apply KVL, what happens? Ri of t plus 1 by C integral minus infinity to 0 I of t dt plus 1 by C integral 0 to t I of t dt is equal to 0. So Ri of t minus Vc of 0 minus, because here we are going to calculate what is the voltage which is present in a capacitor before switching. So we need to take the time period in a negative dimension. So t in negative case, that is minus infinity to 0, will be Vc of 0 minus plus 1 by C integral 0 to t I of t dt is equal to 0. So Ri of t minus 4, okay. So the value which we have got as V of 0 minus will be taken and it is written as Vc of 0 minus as 4 plus 1 by C integral 0 to t I of t dt is equal to 0. So we have got this KVL equation. Now we have to apply Laplace transform. So Laplace transform of I of t is equal to I of s, and Laplace transform of any constant is 1 by s, and Laplace transform of integration is I of s by s. So while applying Laplace transform to this equation, we will be getting Ri of s minus 4 by s plus I of s by Cs is equal to 0. Now we have to simplify this equation and we have to get I of s. Okay, so Ri of s plus I of s divided by Cs is equal to 4 by s, and we take I of s as common outside. I of s of R plus 1 by Cs is equal to 4 by s. So I of s, take LCM, okay, RCS plus 1 divided by Cs is equal to 4 by s. So we cancel the s and s in LHS and RHS. So we get I of s is equal to 4C by 1 plus RCS. So we have constant before the s, so we have to remove it. So we are doing 4C divided by RC into s plus 1 by RC. So we are getting I of s is equal to 4 by R, okay, C and C gets cancelled. So we get 4 by R divided by s plus 1 by RC. So next step is taking the inverse Laplace transform to get I of t. So I of t is equal to 4 by R. So 1 by s plus a, the inverse Laplace transform is a power minus at. So we are getting 4 by r e power minus t by rc. Now we are going to substitute the r and the c value and get what is the time constant. Okay, tau is equal to rc. So r is equal to 10 kilo ohm, c is equal to 25 microfarad. So rc is equal to, we multiply these two values and we get 0.25. So I of t is equal to 4 divided by the r value. The r value is 10 kilo ohm. So 10 into 10 power 3 e power minus t by 0.25. Now we are supposed to calculate what is the voltage across the resistor and what is the voltage across the capacitor. So the voltage across the resistor is given as R into I of t. So we substitute that R, okay, R, that is 10 into 10 power 3 multiplied by the I of t is given as 4 divided by 10 into 10 power 3. So this 10 into 10 power 3 and 10 into 10 power 3 in the numerator and the denominator cancels. So we get VR of t is equal to 4 e power minus t by 0.25. Now we are supposed to calculate what is the voltage across the capacitor. So the total voltage in the circuit is given as VR of t plus VC of t is equal to 0. So Vc of t is equal to minus Vr of t. So whatever charge in the capacitor will be delivered and it is used by the resistor. So it will be Vc of t will be equal to minus 4 e power minus t by 0.2. Thank you.